Okay, question 10, second to last question on the exam paper. Quite a hefty question. It's worth 14 marks altogether, and it's looking at circles, finding tangents, radius, centres, things like that. So the first part, we get given the equation of the circle x squared plus y squared minus 8x minus 6y minus 20 equals 0. So it's equation of a circle. Find the centre and radius of that circle. And they even give you a diagram that looks something like this to help you out. So first things first, I need to complete the square on this equation here. So I've got x minus 4 squared, and I need to take away that number squared, so take away 16. Then completing the square on the y parts, so I'd end up with y minus 3 squared, and then take away 9, and I'm still left with that minus 20 on the end. And then moving all of the constant terms over to the other side of the equal sign, so I'd end up with x minus 4 squared plus y minus 3 squared equals 45. So from that equation now, I can easily tell you what the centre is and what the radius is. So the centre is going to be, the x coordinate is 4 and the y coordinate is 3, just by changing the signs that's in the middle there. So that's the centre of the circle. And then the radius of the circle is the square root of 45. It's just always the square root of the constant term on the other side. So that's the 4 marks for the first question, so that's 3 marks so far. Part 2 is asking us to find the tangent at A. So the tangent that goes across here, we want to find that equation. We're not given any coordinates at A, so we need to find those out. Hopefully you can see it lies on the x-axis, so that's when y is going to be equal to 0. So when y equals 0, we make y 0 in this equation at the top here. Those two parts are going to disappear, so we're just going to end up with x squared minus 8x minus 20 equals 0. And then I need to find out what my two possible x values would be by factorising this. So my two possible values are going to end up being minus 10 or plus 2. And if I found my x values, I would end up with x equals 10 or x equals minus 2. And you can see from the graph that there is that minus 2 value over here, but a is the positive value, so we want to forget about the x minus 2 part. So we need to work with x equals 10. Okay, so we've now got this point here is 10, 0. And we know what the centre of that circle is. We did that earlier, we've got 4, 3. I want to work out what the gradient is going to be of that radius, so then I can work out what the gradient of the tangent is going to be. So the gradient of that radius, difference in y divided by the difference in x. The difference in y divided by the difference in x. So I'm going to do 3 take away 0 divided by 4 take away 10, which ends up giving me minus a half. So the gradient of the radius is minus a half. The normal at that point is going to be the negative reciprocal of that. So the gradient of the tangent is going to be 2. And then I just need to substitute everything I know into y equals mx plus c. So my y value is 0. My gradient was 2. My x value is 10. And my value for c we're trying to find out. So we've got 0 equals 20 plus c. So c has to be minus 20. Putting that all back into my equation, I'd end up with y equals 2x minus 20. So the equation of that tangent is y equals 2x minus 20. Okay, part 3, we're told that there's a second tangent that's parallel to the tangent at A, and we want to find the equation of that tangent. So we've got the tangent here, so we want to find the parallel one, which is over the other side of the circle over there. I need to work out what the coordinate is going to be of that point over the other side. I could work that out by looking at the circle that I've got so far, that little sketch I've drawn, and looking at the triangle that it makes to get to that point. It's going to be exactly the same triangle to get to the other point, so I just need to add those coordinates on. If I work through that, So to go from my x distance, I go from 4 up to 10, so that length is 6. So this length here has to be 6 as well. And also to go in my y direction, this length is 3, going from 3 down to the x-axis. So this length here has to be 3. So I need to add 6 to the y coordinate, x coordinate, and 3 to the y coordinate. So we end up with, or take away 6, sorry, so it ends up being minus 2, and then adding 3 would give you 6. So I'm going to call that point over there A dash. So going back to the question down the bottom, we had that A dash is now minus 2, 6. So that's the point that I need to work out what the tangent is going to be. Because it's parallel to the tangent at A, it's going to have the same gradient. So we know that the gradient is going to be 2. And we've got an x and a y value, so we can substitute those into y equals mx plus c. So y is 6, gradient is 2, x is minus 2, and we've got plus c that we're trying to find out. So 6 equals minus 4 plus c, so c has got to be 10. Putting all that back into the y equals mx plus c stuff, so we end up with y is 2x plus 10 for my equation of that other tangent. Okay, and then part 4 of the next question over the other side. So we've got another circle that has the origin as its centre, and it's got radius r, and the circle lies wholly inside the first circle. So we want to find the possible values for r. So if I go back and look at the diagram on the other side to kind of give us a visual aspect of what we're being asked. So another circle has the origin as being its centre, and it lies wholly inside of the original circle. So the biggest it can be is looking something like that. If I worked out what the distance was from the origin to the new circle, then I would end up working out what my values for r would have to be. If I also looked at the distance of the whole radius, it goes right through there to 4, 3, I could work out the distance from the origin to the radius and subtract that from the whole radius, and that would give me that extra part that's there. So if I go ahead and do that, I'm just going to draw it again a bit separately. So we've got that 0, 0, and then that one there is 4, 3. So that's the radius of my circle. I just want to know this length here. I just want to know that length. So I'm going to work out the length of this and then subtract it from the radius that we found in part 1. So the length of this part here is going to use Pythagoras. So we'd end up with 4 squared plus 3 squared square rooted, which gives you the square root of 25, which gives you 5. So the length of this part is 5. We found out earlier that the whole radius, so the whole part, was the square root of 45. Just to work out that red part that's there, I'd need to do the square root of 45, take away 5, to give me this part here. So the radius of that little circle that has the origin as its centre, its radius has to be less than root 45 minus 5. And that's your final answer.